What if you're given the sides of a right triangle and are asked to find the angle? This is called going backwards, and today we're going to talk about it using tangent. In the triangle to the right, we don't have any angles, but even if we don't know angle A, we know its tangent. Tangent is defined as its opposite over its adjacent ratio. In this example, the opposite of A is 7, the adjacent to A is 9. It's approximately in decimal 0.7 repeating, well, it's actually equal to 0.7 repeating, or approximately 0.78. To find the measure of angle A, we can do one of two things. We can either use the table backwards. So you go to the tan column and look up the angle closest to 0.78. If you go down and find the angle closest to 0.78, it would be 38 degrees. Another way to do it is using your calculator. To go backwards, you would have to type in tan -1 of 7/9 as long as your calculator is in degree mode. And then you'd get approximately 37.87, which the nearest whole integer, the whole angle measure is 38 degrees. So let's practice some using examples. Here we're giving the hypotenuse and one of the legs of a right triangle, and we want to find the measure of angle A and measure of angle C. Using just tangent, however, we would have to find what the opposite to A is, and Pythagorean theorem, if you do that out, you find out that this side is 3. So we would have to do tan -1 of 3/4, which is 0.75. And doing that on the calculator, you get approximately 37 degrees. Again, the other way you could do it is to look up in the table. To look up in the table 0.75 down the tan column and find the angle closest to 0.75. Now, to find the other degree angle, if this is 37 degrees, since it's a right triangle, you know that this one has to be complementary, or 53 degrees. An isosceles triangle has base 10 and sides of 15. Draw a diagram. Draw in and find the exact height of the triangle. The height is the perpendicular distance between the vertex and the side opposite. In an isosceles triangle, this would equate to this being 5. So we do Pythagorean theorem to find the height. We'll call that x. We would do 5 squared plus x squared equals 15 squared. 25 plus x squared. Whoops. Equals 225. X squared equals 200. And we'd have to find the square root of 200. What's the biggest perfect square that goes into 200? It would be 100 times 2. So the answer would be 10 root 2 for the height. Find the length of the 3 angles in the triangle. So let's go ahead and this is what we want to find angle A, and we know that this side here is 5, we know this is 15, and we know this is 10 root 2. So we want to find angle A using tan. So the tan of A is equal to 10 root 2 over 5, which equals 2 root 2. On the calculator, we could do tan -1 of 2 root 2. Or you could calculate 2 root 2 and get that into decimal and look it up in the table. So if you do that, you'll find one of your angles is 71 degrees, angle A. And of course, it's isosceles, so there's another 71 degrees, the other base angle, and the leftover is 38 degrees. Moving on, we're going to set up number 3. Consider the rectangle to the right with sides 2 and 7. Find the measure of angle EDC, which is right here. Okay, so we know this is 2 because it's a rectangle, and this is 7. Properties of a parallelogram, which is a rectangle, and we know a rectangle has 90-degree angles. So if you look at this, this is simply a right triangle. We want to find angle EDC. So we would have tan -1 of 2 over 7, and that will give me the measure of angle EDC. And if we either calculate 2 over 7, look it up on the table, or do tan negative on the calculator, you should get approximately 16 degrees. And now to find EDA, we know that if this is a right angle, EDA has to add up to 90 from 16, so that answer has to be 74 degrees. Just another question. What would be the measure of this angle here? I'm going to call it AEB. AEB, right here. Angle AEB. Well, we know that this is 16 degrees. We know this is 16 alternate interior angles. And do you remember the property of a rectangle and the diagonals are congruent? Actually, the diagonals are congruent, which means the pieces of the diagonals are congruent. So these would all be isosceles triangles. If this is 16, this is 16. And you could find the leftover here by doing 16 plus 16 and subtract that from 180. Oh, I just did B. Although I didn't do, I didn't find the acute angle. We're finding here the obtuse angle. So you'll have to do a little bit more work for B. I'll set up number 4 and we'll check our work tomorrow. ABCD is a rhombus with diagonal lengths of 16 and 30. We have to remember our properties of a rhombus. So the diagonal lengths are 16 and 30. So some of the properties are that the rhombuses form right angles. The other one is that, of course, they bisect each other. So if this whole thing is 16 and this is 8, BD whole is 30, so half of 30 is 15. So I see a right triangle here, so I think you could be set up to find the exact length of the sides of the rhombus. The next question asks you to find the 4 angles. Complete this for homework.